Welcome Unity programmers to this new lesson. In this lesson we will cover the following topics. We start with the introduction. That's what we're doing right now. Then I'll introduce the canvas and the different render modes. And I show how to tailor the UI to different screen resolutions. And I show how you can automatically adjust the value of a score label to a changing score. We end the lesson with the outro. This was the introduction. Let's quickly start the lesson. We made a nice game, but we have no idea how well we are doing. There is no feedback to the player about how many meteors he shot out of the sky, or how many were missed. The easiest way to provide the player with feedback is through a user interface. With the help of a UI, we can provide information to the player about his or her progress. We want to textually show what the player's score is and how many lives he has left. I also want to limit the amount of bullets available. So, you will need to add some text labels to the scene where we can visualize this data. When creating a new UI element, such as in text field, Unity automatically creates a canvas if there isn't already a canvas in the scene. The UI element is created as a child to this canvas. To add a text component, right-click in the hierarchy and select UI, and then Text Mesh Pro. If you have not yet used text in your project, Unity will first need to import some resources. As you can see, the added text component is placed as a child of an automatically added canvas in the hierarchy. An event system object has also been automatically created in the hierarchy. An event system contains several input modules. These modules are responsible for deciding how game objects in your UI respond to input. Before we go to the text component, I want to take a quick look at the added canvas. The canvas has 3 render modes. The first mode is Screen Space Overlay. This render mode places UI elements on the screen rendered on top of the scene. If the screen is resized or changes resolution, the canvas will automatically change size to match this. The second mode is Screen Space Camera. This is similar to Screen Space Overlay, but in this render mode the canvas is placed a given distance in front of a specified camera. The UI elements are rendered by this camera, which means that the camera settings affect the appearance of the UI. Last mode is World Space. In this render mode, the canvas will behave as any other object in the scene. The size of the canvas can be set manually using its rect transform, and UI elements will render in front of or behind other objects in the scene based on 3D placement. We select the Screen Space Overlay mode for this project. We rename the text component as Score Label. If we want to position the label in the desired location, we must first determine the anchor point. I choose the top left corner of the screen. If we set the position on the X and Y axis to 0, the label will move to exactly the top left corner. To get a full view of the canvas in the scene view, you can select the canvas and then press F key with the mouse cursor in the scene view. Now we can position the label by determining the distance on the X-axis and Y-axis from the top left corner. With a font size of 100 and a label width of 500 and height of 50, the label gets a nice position. We change the text of the label to Score 0. We can duplicate the score label by selecting it and pressing Ctrl or Command+D. Rename this label to Lives Label. And change the text component to Lives 5. Move the label slightly below the existing label by changing the value on the Y-axis to -250. And duplicate this new label. This can also be done by right mouse button and select Duplicate. We call this label Bullets Label. and change the text component to bullets 5. We also want to place this label slightly below the second label, so we change the value of the y-axis to -400. Our UI looks good on this screen with this resolution. But if we choose a different resolution, the UI will look less attractive. To make the UI look good at all resolutions, we need to adjust the canvas scaler component. We need to adjust the UI scale mode to scale with screen size. Select the canvas, and select Scale with Screen Size from the UI Scale Mode pull-down menu. An option will now show up to specify the reference resolution. We designed our UI according to a resolution of 3840 by 2160. If we now change the resolution, the UI will remain the same in relation to the resolution. This way we can be sure that the UI adapts to the resolution and that the UI does not get in the way of the gameplay. It is also possible to choose a simulator so that you can try out what your game looks like on a mobile device. If you select the simulator, you can select your preferred device in the pull-down menu. If your preferred device does not appear in this list, you can install additional devices by pressing the button with this name. The UI continues to look good also on these devices. Let's select the original resolution again. We now have an UI that looks good on all screen resolutions. Only the UI is static. We have no way to update the UI. The score remains 0, no matter how many meteors we shoot out of the sky. Let's start by building in the ability to increase the score every time you shoot a meteor out of the sky. Let's open the Game Manager script. The keyword using imports a namespace. Namespaces are a collection of classes and other data types from a library. In this case, we are importing TextMesh Pro. Then we declare a public TextMesh Pro UGUI variable called scoreLabel. TextMesh Pro UGUI is used for text elements when working with a canvas, as we are doing. In the editor, we can use the text element of the canvas as a value in the Game Manager variable. Through this variable, we have access to the text element of the label. As an example, we give the text element a string value test in the start method. We can test this in the editor. First, we open the Game Manager object and add the score label to the score label variable. If all goes well, the text test will appear in place of the score label. As you can see, it works. Let's reopen the Game Manager script. In addition to a variable for the text label, we also need a public int variable to store the score. We can use the int variable score in the text value of the score label to display the score. To test, I first change the score to 100. Instead of the value test, we change the string value to score : space. Behind this, we place a plus symbol with the score behind it. We just need to change the int score to a string using dot to string parentheses. If we test this in the editor, a score of 100 should appear. However, the score still doesn't change if we shoot a meteor out of the sky. If we want to increase the score when a meteor is shot from the sky, we need to open the bullet movement script. Here we have programmed what happens when the bullet hits a meteor. In the onCollisionEnter function, we increase the public int variable score by 1. Now we have to open the Game Manager script again. We remove line 19 because we want the score to start at 0. If we want the score to change in real time, we have to copy the code from the start method into the update method. Now the score should increase by 1 as soon as we shoot a meteor out of the sky. As you can see, the score changes by 1 as soon as a meteor is shot out of the sky. Now let's end this lesson, otherwise it will be a very long one. For the next lesson, we can adjust the other two labels to match the state of the game. Thanks for watching. In the next lesson, we're going to update the other two text labels to match the game state. Please like and subscribe, so you'll get notified if a new video is uploaded. More people will get this video in their search result when they want to learn Unity game development.